Hello everyone, so in this video, let us talk about one more problem from LeetCode. The problem name is keys and room. So the problem statement goes like this, that there are n rooms labeled from 0 to n minus 1 and all the rooms are locked except for room 0. Okay, now your goal is to visit all the other rooms. However, you cannot enter a locked room without having its keys. Sure. So when you visit a room, you may find a set of distinct keys in it. So every room has some keys present in that particular room. Now each key has a number denoted on it which defines that which room this key opens. Okay. Now the overall problem is that you're given an array of rooms. As you can see here, the rooms of I contain a set of different keys it can open. Now your overall target is to check that whether you are able to visit all the other rooms throughout this whole process, and the room 0 is only open for you. Let's just take this and this example to clarify what it is. So as you can see that this is room 0, room 1, room 2 and room 3. Now what you can see is that room 0 is already open. When you enter room 0, you have a key that is of room 1. So now you can go to room 1. Now room 1 is this. When you go to room 1, it has a key of room 2. When you enter room 2, it has the key to room 3. And room 3, when you enter there, doesn't have any key, but because there are only this number of rooms only, like the 4 rooms, so you have visited all the 4 rooms and the answer is true because you're able to visit all the 4 rooms. Coming down to the next example, you're here. So you enter room 0. So room 0, 1, 2 and 3. So you enter room 0. So as you can see that room 0 is here and it has the key to room 1 and 3. So this is the room 1 and let's say this is the room 3. Okay. Now room 1 again has keys to 3, 0 and 1. So room 1 has a key to room 3, room 0 and room 1 itself. Okay. So room 2 has the key to itself and room 3 has the key to room 0. Now what you can see is that if you start from this room, you can travel all these 2 different rooms, but you cannot travel to this room because this is not connected. The key for room 2 is present inside that particular room itself, and thus you are not able to reach or open this room, and thus the answer is false because you're not able to reach all the rooms. And thus that's the whole problem statement. Now what you can directly see that this is a graph, so you can directly just use different traversals over this graph. Pretty much simple traversal is BFS. Why? Because you are doing layer wise traversal. You will first go in one room, then all the rooms that are attached to it, then all the rooms that are attached to it, and so on. So all the rooms, so it's a graph. You can just traverse it using BFS. You have to also maintain that which room you are already visited, so that you do not revisit the same room, because they are like you can say bi-directed edges, because you can go to this room and from this room you can go to back to this room, so it might not lead to a deadlock. So for that you can just create a visited array that will store out what all rooms you have already visited and you should not visit it again. And thus this is the overall idea. This is just the BFS. Let's move on to the code part, and if you still have any doubts you can mention it in the comment box for this particular problem. So what you can do is that for BFS you have to first initialize a queue. Okay, and then what we'll do is that we have to maintain a visited array so that we know that which room we had already visited and which room are yet to be visited. Now because we start from room 0, so we will start room 0. So we will push this 0 inside the queue, which means that room 0 is open. We can start from there. Now we will do this while loop, which means that we will keep on doing this whole procedure again and again until like there's an end. We cannot go more. Now what I'll do is that I have room 0. So what I'll do is I will first take out the first key of the, let's say from the queue, pop it out, and then let's say I have room 0. So what I'll do is I will check that whether room 0 is already visited or not. So it is not visited because I'm just going in the very first time. So when I'm going in the very first time, I will mark it 1, which means that now I'm going in the very first time. I visited now. So I will mark this particular index or like whatever key I have, that is let's say 0 here, as 1, that I visited now. I should not go in the room 1, like room 0 again, because I've already visited. Now when I'm going in the room 0, what I will find out, I will find out keys to different rooms. So what I'll do is I will do a for loop over all the keys present inside this room, and I will push it in the queue itself, so that we will completely do iteration over each room one by one, that is pushed inside the queue, because that's just the BFS manner, and that's it. And then you will just keep on doing this operation until the queue becomes empty. You will keep popping out elements, and if you have already visited that room, you will not visit it, because if you have already visited 0, you have pushed all the keys to queue. Why you will push it again? If you have already pushed, you have already visited, then they will be marked in the visited array. Now visited array store all the rooms that you have visited. So in the end what you will do is that you will iterate over all the rooms that you have visited in the visited array. If you find out any room that is not visited, that is you have marked the visited room as 1. If you find out any room that is not visited, that is visited of I equal to 0, so then you will return false, that there exist some rooms that you are not able to visit throughout this whole process. So answer is false. If all the rooms are visited, if this condition doesn't meet, then answer is true, that you are able to visit all the rooms. That's the overall idea for this particular problem. And you still have any doubts, you can mention down. Thank you for watching the video till the end. I will see you in the next one. Thank you, coding, and bye.